Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video we are going to solve this question based on the radioactive decay that was asked in IIT JAM 2006 paper. So what is given to us is a half-life is given, initial activity is given 6400 disintegration per minute, and we have to find out the activity after 100 years. So how do we solve this? The first important thing to be understood is that radioactive decay also follows first order kinetics. Radioactive decay also follows which order kinetics? First order kinetics. And so everything is same as that of the first order kinetics? No. There is only one change, that is instead of rate constant K, the symbol is different. We say, what is that? We say lambda. Okay, instead of rate constant K, we write lambda, that is the decay constant. Okay, formula, all the formulas will remain the same. So what is given to us is half-life is given, that is 20 years. Then initial activity is A naught, that is given to us 600,400 disintegration per minute. Time is given 100 years. After 100 years we have to find out the activity 80. Okay, so 80 is question mark. So what are the formula that we write for the first order kinetics? First is for the half-life. 0.6 T half is half-life, 0.693 divided by, instead of K, now we write lambda. What is lambda? Lambda is the decay constant. What is another formula? Lambda is equal to 1 by T ln of natural logarithm base will be E A naught by AT. Okay, so what is lambda? Decay constant. T is time, A naught is initial, there it was initial concentration of the reactant. Here it will be initial activity. AT is the activity after time T. So now if you see here, we have to calculate AT. So for that we have A naught, yes. We have time, yes, we have 100 years. Lambda, no, we don't have lambda. So for lambda we will use this formula for half-life. Half-life is given, so we can calculate lambda. So first what we will do is, first we will calculate the value for decay constant. So decay constant will be 0.693 divided by T half is 20 years. Okay, this you solve, this comes out to be 0.03465. Unit will be, this is e raised to 1, it will go to the numerator, it will become e inverse. Okay, so now we have got lambda. So lambda into T. So ln of base is E, A naught is given, that is how much? 6400. 6400 disintegration per minute. Okay, divide by AT is what we have to calculate. Okay, is equal to lambda T. Lambda is 0.03465. Okay, year inverse multiplied by how many time is given? 100 years. Time given is 100 years. So you can see years and year inverse get cancelled. Okay, that is what we want, because e raised to anything, that should be a number with no units. Okay, so now how do you remove this log? You do e raised to this value. So 0.03465 into 100 means you have to shift this two places to the right. So this will be 3.465. So 6400 disintegration per minute divided by 80 is equal to e raised to this value 3.465. Okay, this comes out to be 31.976. Okay, 31.976. So let me solve here above. So what is given now? Now we have to do the last step. How do you calculate 80? Cross multiply. Okay, cross multiply. 80 will be 6400 disintegration per minute divided by 31.976. So the final answer is 200.15 disintegration per minute. So you have to always remember, whenever you solve physical chemistry question, the final unit you have to check is very important. Disintegration per unit. In the question also they have asked in disintegration per minute. If it was disintegration per second or some other unit, then you have to change. You have to do the unit conversion. but it is disintegration per minute. So the correct answer is option C. I hope you have understood all the steps. Thank you.